This video is about how to write conclusions for hypothesis testing. When conducting a hypothesis test, the conclusion is maybe one of the most important pieces of the process. So remember, a hypothesis test has four pieces. You write your null and alternative hypotheses. You check that the CLT can be applied. You get StatCrunch to give you a test statistic and p-value. And then based on your test statistic and p-value, you make a conclusion about your null and alternative, about your hypotheses, okay? Now, typically, on an exam, one of these problems will be worth 6 points. If you do steps 1, 2, and 3 correctly, but you blow step 4, automatically -4 points on your problem. And sometimes people say, well, that's harsh. I did all these other steps correctly. If you do the other steps correctly, but don't know what they mean, don't know what they tell you about your population, then it really was for no point in doing those other steps. So some people are focusing, I think, too much on the little steps that lead up to the conclusion and not enough on what did all the steps mean. So please, 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 you have to pay attention to how you write your conclusions, because if you blow the conclusion on a hypothesis test problem, -4 automatically. Because the point of doing a hypothesis test is to understand what the process told you about the population. So let's practice writing conclusions. Now, what I've copied here on this document are from the section 8.2 notes. And probably I should maybe do some graphics. I'm not good at graphics, but this right here from the 8.2 notes that are posted in Canvas, really important because this tells you exactly how to write your conclusions. So please review this and I'm going to do some examples, all right? So suppose you have hypotheses, and I think this was from a recent problem set that we did. We wanted to see if more than 40% of the people had seen an advertisement. So our null hypothesis was that the population proportion was 40%, and the alternative was the population proportion was greater than 40%. Okay? So you make a decision based on the p-value, because the p-value is going to tell you whether something is unusual or not. So we establish a cutoff, which is called your significance level. Usually it's 5% unless you're told otherwise. And in this zone, we're going to reject our null hypothesis. And in this area, we're not going to reject our null hypothesis. Because what we're doing is we're weighing the evidence, and the evidence is our sample proportion. And we want to know if that sample gives us evidence about the population, about the entire group. Okay? So in this problem, suppose P is equal to, say, 0.02. Then you would reject the null hypothesis. And if you reject the null hypothesis, you believe this is true. So when you reject the null hypothesis, what you write is evidence suggests, and then you complete that sentence with your alternative hypothesis in plain English, meaning in words that someone who's not taking statistics would understand. You answer the question. So evidence suggests more than 40% have seen the ad. If you had a p-value of, say, 0.19, then you would not reject the null hypothesis. When you don't reject the null hypothesis, you write, there's not enough evidence to conclude. And then you complete that sentence with your alternative hypothesis in plain English. So there's not enough evidence to conclude more than 40% have seen the ad. So that's what this paragraph says in the section 8.2 notes, but it is very, very, very important. Here, let's do another example. Suppose your null hypothesis and your alternative hypothesis, let's see. Suppose we want to know, has opinion on global warming changed? And so maybe we have two sets of data, and we want to know if they're different. So our null hypothesis, no, the two proportions are still the same. And our alternative would be, no, there's been a change now that they're different. Suppose you get a p-value of 0.03. You would reject your null hypothesis. That means you believe this is true. And what would you write? Evidence suggests. And again, you complete this with your alternative hypothesis in plain English. So what does P1 not equal to P2 mean? We were testing has opinion changed, and that means evidence suggests opinion has changed. In other words, the proportions are not the same now. Suppose you came up with a p-value of 0.08. Then you would not reject the null hypothesis. And you would write, there's not enough evidence to conclude and you would still finish that with HA in plain English. So if you don't reject the null hypothesis, then there's not enough evidence to conclude that opinion has changed. This is really, really, really important. Writing conclusions to a hypothesis test is not a time to engage in creative writing. It's not the time to put your own spin on things, because sometimes when you do that, you accidentally make a mistake. For example, you accidentally say things like, you proved that opinion is the same. Saying that there's not enough evidence to conclude that opinion has changed is different from saying opinion is the same. And again, these notes from section 8.2, these really, really, really important notes, explain why that's true. We can never prove that the null hypothesis is true. That's why we always write about the alternative. And the way that we can think about this kind of, again, this is in that paragraph, but when someone's put on trial, the null hypothesis is that the person is innocent. And the alternative hypothesis is that the person is guilty. And the jury weighs the evidence. If they reject the null hypothesis, then evidence suggests. And what's the alternative? The person is guilty. When they don't reject the null hypothesis, meaning they weighed the evidence and it wasn't convincing, then there's not enough evidence to conclude. The person is guilty. The jury comes back and says, we find them not guilty. The jury never comes back and says, we find them innocent. Okay? It's maybe subtle, but it's very, very, very important. Is there a chance that we've made a mistake? Absolutely. There is a chance that we've made a mistake in our conclusion. But, getting back to this picture, the probability that we've rejected the null hypothesis when in fact it was true is very small. So when a jury comes back and says we weighed the evidence and found them guilty, is it possible they put an innocent person in jail? Yes, but if the system has worked correctly, it's highly unlikely. When the jury comes back and says there's not enough evidence to convict them, the person's not guilty, is it possible they've made a mistake? Absolutely. We can think of very famous court cases where we suspect that the person actually was guilty, but the jury didn't convict them. All right, so it's not a foolproof process. That's what the significance level is for. But pay close attention to how you write your conclusions. And if you have any questions about that, please, please, please just reach out and we can go over it some more.